September 9, 2010, 6:11 p.m. In the Glenview district of San Bruno, the ground opens up. A 30-inch steel pipeline ruptures, igniting a pillar of fire visible for miles. A high-pressure blowtorch fueled by 47.6 million cubic feet of gas. 8 people will die. 58 will be injured. 38 homes will be destroyed. A crater 72 feet long marks where the infrastructure failed. Emergency crews arrived within minutes. They were helpless, unable to even approach the source of the Glenview district fire. But the most terrifying detail wasn't the heat. It was the fact that for 95 agonizing minutes, no one knew how to turn it off. The rupture occurred on PG&E's line 132, segment 180, a major gas artery beneath a residential neighborhood. PG&E's own records listed this segment as seamless pipe, one solid piece of steel, inherently stronger because it has no weld. But that was wrong. Segment 180 actually contained longitudinal seam welds, a detail buried under decades of poor record-keeping. Making it worse, a regulatory loophole called the grandfather clause exempted pipelines installed before 1970 from modern hydrostatic pressure testing, the process of filling a pipe with water at high pressure to expose hidden flaws. Because of this exemption, segment 180 had never been properly stress-tested. PG&E was missing manufacturer data for nearly 80% of line 132. They were, in every meaningful sense, flying blind. The flaw itself dated back to 1956, when segment 180 was relocated. Workers used short pipe sections called pups. One of them contained a defective weld, incomplete fusion between two edges of steel that had never properly joined. For 54 years, it sat beneath the soil. On September 9, 2010, a routine project at the Milpitas terminal set off the chain reaction. At 4:18 p.m., the SCADA system, the nerve center for pressure and flow data, went dark. Automated controls began to fail. By 5:21 p.m., regulating valves had defaulted to 100% open, sending a massive gas surge into line 132. Over 60 alarms fired in the control room. Operators, conditioned to treat SCADA glitches as routine nuisances, didn't grasp the severity. By 6:04 p.m., pressure hit 396 psig, above the legal limit of 375. At 6:11 p.m., the 54-year-old weld finally gave way. Millions of cubic feet of gas erupted and instantly ignited. San Bruno fire units arrived 2 minutes later, met by a wall of fire too intense to approach. Because line 132 used manual valves, PG&E employees had to physically drive to remote locations and turn heavy wheels by hand. It wasn't until 7:06 p.m., nearly an hour after the explosion, that a mechanic identified the rupture location. By watching news coverage on TV. The upstream valve closed at 7:30 p.m., the downstream valves at 7:46 p.m. 95 minutes after it began, the flow stopped. Secondary fires from local distribution lines burned until 11:32 p.m. NTSB investigators found exactly what PG&E's records had failed to document: a pup section with a catastrophically substandard seam weld. Metallurgical testing confirmed incomplete fusion, a crack that had grown slowly over 5 decades until it reached a critical size. The investigation exposed the full scale of PG&E's data failures. They were missing wall thickness values for 41% of line 132. Because they believed the pipe was seamless, they used inspection methods that could never detect a seam weld defect. They weren't looking for the right problem because they didn't know what was in the ground. The NTSB also pointed to the human factor. operators so desensitized to nuisance alarms that they lost critical response time. A pipeline with no remote shutoff valves, leaving the speed of a truck in traffic as the only defense. The consequences were severe. The California Public Utilities Commission launched a sweeping investigation, and total costs to PG&E exceeded $1 billion, tied to fines, mandated infrastructure upgrades, and its subsequent bankruptcy. PG&E was found to have violated multiple federal and state safety regulations. Investigators described a corporate culture that incentivized managers to defer safety inspections to hit budget targets. But the more lasting change was regulatory. The San Bruno gas line rupture effectively ended the grandfather clause. Regulators now require all transmission pipelines, regardless of age, to undergo hydrostatic testing or be replaced. The industry accelerated adoption of smart pig technology, robotic tools that travel inside pipelines to detect cracks and corrosion from within. Manual valves began to be replaced with automatic shutoff valves and remote control valves that can detect pressure drops and close automatically. As utilities across the country continue to modernize aging systems, the lessons of Line 132 remain essential.